Hey guys, welcome back to the channel. Today we'll be solving LeetCode 200, number of islands. So we're given an m by n 2D binary grid, which represents a map of ones and zeros, and we need to return the number of islands in this map. So an island is anything connected by ones horizontally or vertically, so not diagonally. So these four are connected and these two are connected, and this one is connected to this island as well because they're connected vertically, and these two are connected as well. So there's only one island in this case, but in this case there's three. These four right here are not connected to this one because it's diagonal, and then there's two here as well. So we can solve this efficiently using a depth first search approach and two for loops. Okay, so the way we're gonna solve this is we're gonna loop through the entire matrix, and if we ever encounter a island, so if we ever encounter a one, so in this case green, we're gonna start a depth first search or a breadth first search. It doesn't matter in this specific problem. I'm gonna do a depth first search, and we're basically just gonna spread vertically and horizontally and look for other green squares. And if we find any green square, we're just going to make it into a blue square. That way we don't go to it twice. And before we start this depth first search, we're going to increase the count variable, or in this case, the result variable, by one, because when we encounter one green, we count one island, and it's going to spread and turn the entire island into blue, so we don't count that one again. So let's go through an example and show you how this works. So we're going to loop through this entire thing and see that this is green, or a one in this case, and we're going to start a depth first search. So we're going to try to go left, and we realize we can't go left, so we're going to try to go upwards. We can't go upwards. We're going to try to go right, and we can, and we see that this is another green square, and we try to go down and it's another green square. But before we move on to the other squares, we're going to turn this into a blue so we don't visit it again. So we turn that into a blue square. Now we're moving on to this one, and we turn this into a blue square, and then we try to go right and down all the directions, and we realize we can go down because there's another green over here. We turn this into a blue. We already went down to this one from the top left, so this one's also going to be a blue, and we realize, oh, we're done. We can't find anything because we can't go diagonally. We found everything that we could from this specific one, so now we're going to move on to the rest. We're just going to keep iterating, so we can use this, and we're just going to keep moving on. Realize none of these are ones or greens, so we're just going to keep going, keep moving, and we find this, and we realize that this is the only square. We do a depth first search, but we find we can't go anywhere else. It's the only square, and we mark it as blue. But now at this point our result variable is 2, because at every iteration, if we find a green, we're going to add 1 to it. So right now it's 2, and then we're just going to keep going. We're going to move on to, and we see nothing here is green, so we eventually reach here, and we realize that this turns into a blue, and then the one to the right can also be reached, so it turns into a blue. And after that, we basically have our result variable set to 3, and everything has turned into a 0 or a blue, and we're done. And we can just, the time complexity of this solution is going to be O of m times n, where m is the number of rows and n is the number of columns. And that's because we have a nested for loop, and the memory complexity is going to be O of m times n as well. And that's because of the recursive call stack, because we're making recursive calls when you have to store the previous call stacks. To begin, we're going to initialize two variables, rows and columns. And these are going to be constants, so we can capitalize them. So rows are going to be the length of the grid, and columns is going to be the length of the first element in the grid, or any element, doesn't matter. And then we're going to make a results variable, initialize it to 0. So before I code up the depth first search function, I'm actually just going to go straight into the nested for loop, and we can just do that like this. We can loop through the rows and get each row, and then the columns using the columns variable. And then if any point in the grid, if we ever reach a point that's 1, we know this could potentially be the start of one island. So we're going to increment result by 1, and then we're going to do a depth first search like this. And after that, we can just simply return the result. So let's code up the depth first search now. So we could just call it DFS, and we're going to take a row variable, which is going to be an integer, and a column variable, which is going to be an integer as well. And this is not actually going to return anything, so we can just put none for that. Now we have to handle some edge cases. So if the row we're currently on is less than 0, it's out of bounds. Or the column we're on is less than 0, that's also out of bounds. Or the row is greater than or equal to the rows variable. Oh, forgot that I capitalized that. So we just change that. Or the column that we are currently on is greater than the columns variable. So the reason we have to do this is because when we do a depth first search, we're going to check left, right, top, and down. And this condition will check if it's out of bounds. And the last thing we have to check is if it's either not a start of an island or it's just simply already visited. And we can check that by seeing if it's 0. And in that case, we just want to return. We don't want to do anything. And once we've made sure that this is a valid point in the grid, we can say it's visited by setting it to 0 like this. And then we want to do some recursive calls to the depth first search like this. So to go to the left, we will do row -1 and keep the column the same. If we want to, or not left, up. So this is going to take us upwards because the row is actually going to make us go upwards, and this is going to make us go downwards. This is going to be left, and this is going to be the right. And this is pretty much the entire code, and we can just run it and see if it works. Looks like it worked, and as you can see, it's pretty efficient.